In the design and construction industries, a lot of emphasis is placed on new buildings. But what about those buildings that are already here? While these buildings may have been constructed before the latest codes were in place, that doesn't mean they can't be high performing. In this series called Enduring Places, we answer questions owners may have about increasing resilience in their existing buildings. For this conversation, we've brought together experts in energy resilience who will talk about what changes building owners can make to ensure their buildings evolve with the changing energy landscape, whether that's improving efficiency of building systems and envelopes or generating energy locally. Bill, let's start with you. We're already seeing buildings and portfolios shaping energy use, not just consuming it. How can buildings become an energy asset?
Generating, storing, and sharing energy are reframing buildings as an active part of energy resilience. These strategies that are being deployed for new buildings and also existing buildings. And there's four of the strategies that I would like to briefly describe. First, the integration of renewable energy and battery storage. Buildings can host solar PV systems and on-site batteries to generate their own energy and store that energy locally. Next, microgrids. Microgrids create localized energy networks within campuses or portfolios of buildings that allow each building to operate independently during grid outages, supply interruptions, and climate events, and can even support surrounding infrastructure. Moving over to the balance sheet, energy resilience is a value driver. Beyond sustainability, resilience reduces risk, can reduce cost, and enable participation in utility-sponsored programs that can provide cost savings. An example of this is demand response programs. Finally, portfolio-level optimization. Owners can aggregate multiple buildings, either on a campus or even within a community, into virtual power plants, shaping energy use and providing flexibility to the broader grid. WSPs work with grid modernization, grid resilience, data centers, decarbonization, and tracking regulatory changes is directly tied to our future-ready efforts, and we are helping clients prepare for what is next. Let me share a few examples. WSP is the engineer of record for the largest renewable-powered transit depot microgrid in the United States. The project includes integrated solar PV, battery energy storage, and green hydrogen production, supporting charging for 200 zero-emission buses by 2035. In addition, WSP is currently completing a campus energy reliability assessment for 3 major United States universities. The work involves evaluating existing energy infrastructure and proposed strategies for distributed energy integration, microgrid readiness, and electrification, all done through a resilience lens. Our work will position these campuses and their existing buildings to improve energy reliability and resilience, reduce carbon emissions, and participate in cost-saving energy utility programs. These are just 2 of many examples of how WSP is looking at buildings and the built environment as an energy asset.
Thanks, Bill. You mentioned a campus project, which leads to my next question. Zach, you tend to look at energy resilience from a portfolio or a campus perspective. Campuses and building portfolio owners are facing increasing pressure now to stay reliable and cost effective, and energy security is at the center of that challenge. If you were advising a campus today, what's the one thing you would tell them to do?
Yeah, great question. So whether you're focused on resiliency, cost, or emissions, it's essential to recognize where your building sits in relation to the utility grid and how to optimize how you interact with it. So understanding how reliable your power supply is to your campus or across your portfolio, where your feeders are coming from, what are the price structures for energy consumption, demand, and even demand response. All of this can help you assess the value of potential resiliency solutions like energy storage. So for our work at the campus of UCLA, we worked really closely with the utility LADWP to understand the maximum electrical draw from the existing circuits and the potential costs and timelines for adding capacity for a future fully electric campus. Now, we quickly realized that serving the new peak energy demands with an energy storage system would not only be cheaper and faster to deploy than a new substation, but it would also create opportunities to reduce operating costs and grid stress through peak shaving. So really, that's a win-win from both a life cycle cost and a resiliency perspective.
Yeah, I agree. So some of the risks for buildings are the loss of utilities due to specific climate events. So in addition to the grid capacity constraints. Jeff, maybe you can share a little bit about what makes energy resilience both a smart investment as well as a sustainability move.
Yeah, thanks, Amy. So, I mean, in my mind, energy resilience just means a resilient building, right? Having resilience on energy means that the building is resilient, and that's just a more valuable asset. So, I'd like to think of it as not just energy as a standalone factor, but doing things outside of just energy, and that can mean having a backup source of power, just providing some emergency backup generation. In very simple terms, it can mean moving away from fossil fuels and focusing on utility sources to sort of be focused on a new decarbonized future. Or it can just mean having flexibility in utility assets and having the ability to respond to grid changes and utility cost changes. We have one project example, Rubin Hall, which is a renovation of a 100-year-old student residence. Much of the project was focused on decarbonizing and providing a air source heat pump solution to replace a fossil fuel steam boiler, which was helping them be energy resilient in the way that they were responding to New York City local law 97 emissions limits. So it was going to reduce potential fines, help them on that perspective, and reduce the campus overall utility based carbon, which was one of their long-term goals. But that project was much more than just a conversion to an electric source. That project was a major renovation and a passive house retrofit for the whole facility, which provided resilience and value in other ways, insulating the walls, adding triple pane windows, improved the thermal comfort of the space, but also improved the acoustics and really created a quiet student environment for these first-year residents, which was a huge win. Adding the heat pumps not only provided a fossil fuel-free heating system, but also added cooling when there was none previously. And we provided a central ventilation system, again, when there was none previously, which improved the air quality and student experience in the space. So lots of things that were not just focused purely on energy resilience, but added to that create more value for the building as a whole.
Yeah, that's really interesting. So building off your example there, Jeff, it's really important to note that different buildings and different usage types force us to think about resilience in different ways. But the essential part is promoting the continuous operations of each building's essential functions. So for another project, Oregon State Treasury Resilience Building, the mandate for resilience was pretty comprehensive. We needed to keep the building near fully operational for at least 2 weeks following a major disaster, which is a very high threshold for resiliency. And that included a possible 9.0 magnitude earthquake. So this, of course, means structural or seismic resilience, but it also means having multiple sources of emergency power and advanced controls to extend the runtime of the building when disconnected from the energy grid. So this extension of runtime allows the Treasury staff and their IT infrastructure to operate and ensure that emergency response programs have the resources they need to provide those essential services. So very critical to the state of Oregon. So this project was an example where we were actually able to take systems and strategies from the campus scale and kind of optimize them for a single building. So we integrated solar panels, lithium-ion batteries, and diesel generators through a microgrid controller serving one building that allows the building to seamlessly switch between energy sources as needed. The control strategy also tied into the building smarts for additional runtime, engaging a resiliency mode, which reduces the power consumption by dimming the lights, setting back the HVAC system set points, and dedicating power to only those essential functions in an emergency scenario. So another key lesson we learned on this project is that resiliency and energy efficiency are not necessarily competing interests on a project with a fixed budget. We were able to deploy passive efficiency, energy recovery in our systems, and heat pumps to reduce the normal and emergency power consumption. So it supported both the reliability mandate and helped the building drive towards net zero energy during normal operation. So it's another win-win.
Okay, So we've talked a bit how to power a building in case of an emergency and whether that be with backup generators or battery power. But one concern that often comes up with all electric buildings is that if the grid goes down, that means all systems are down, including heat. So how do you respond to that question? Anyone?
Yeah,
Jeff?
Amy, that's a question I get all the time. We talk a lot about electrifying buildings and responding to different jurisdictions push towards that, and folks are often concerned about losing heat when power goes down. The truth is that even if you have a fossil fuel heated building, unless you have all of your ancillary systems backed up by emergency power, you're still going to lose heat. If your pumps aren't running, you don't have hot water in your radiators. So that's a common misconception that we need to get around. Now, that doesn't answer the question. Like if you lose power, you still lose heat if you have an all electric building. But there's ways to address that. And one, back to the Rubin Hall example, I mentioned earlier that we provided ventilation air for that facility. We also provided an emergency generator when previously there was none. So that building did not have heat backup in the loss of power, in the event of loss of power previously. But when we did this all electrified solution, we added a generator to provide emergency power for all of the HVAC systems. Would have been a super big generator that frankly we didn't have the room for. But what we did do is we provided emergency power for those outside air systems, which coupled with all of the passive house and envelope improvements, effectively provides what we had termed a habitable space. Even if you lost power for a long-term condition, you would still have the ventilation air providing conditioning to a degree that would maintain a space that people could live in any time of year. So that's kind of one way that we respond to that, selecting something in the system and providing power for it to kind of answer that question in a successful way.
Great. Thanks, Jeff, for continuing on that example. As we've heard here, energy resilience really isn't just about keeping the lights on. It's about creating a built environment that can adapt, endure, and empower owners and users in the face of an uncertain future. As more buildings electrify and as distributed energy resources become more common, it's clear that we must continue to evolve our thinking about the relationship between buildings and the grid. Given that it's estimated that up to 80% of buildings that exist today will still be here in 2050, we can't afford to ignore existing buildings' role in our energy resilience future. At WSP, our experts in building energy systems, portfolio level decarbonization planning, and power are working together to rethink how we design for the future and how to make sure that the owners see the opportunities for the buildings to not just weather the coming changes, but to thrive in a new environment. Thanks to our participants for sharing their insights, and thanks for tuning in to this session of Enduring Places.